Hello there, warriors. It's Miss Lemons, and today I'm going to be walking you through the first portion of part 3 of the average atomic mass worksheet. So it says calculate the average atomic mass. The image to the right represents a naturally occurring sample of magnesium. Consider the image as you answer the questions below. First, determine the number of naturally occurring isotopes represented in this sample. How many different isotopes did you find? Okay, so we're going to be looking at all of these atoms, and notice that they all have Mg as their symbol, which means they're all made of magnesium. And notice that the bottom number, 12, is the same for all of them because 12 represents the atomic number, which is also the number of protons, and we know that all atoms of the same element have the same number of protons because if you change the number of protons, you change the element. Okay, so let's go through and kind of look at the different types of atoms I have in this sample. I'm going to use a different color for each one. So I've got 2612 and 2412 and 24, 24, 24, 24, 24, 24, 24, ooh, 25, that's a new one. 24, 24, 24, 24, 25, 24, 26, 24, 24, 24. Okay, so I have already identified that I have 3 different isotopes in each of those. And then you're going to be creating a column for each one of the isotopes. So because we found 3 isotopes, we need 3 columns. So first, the isotope name. We are going to first look at the green one. It has a mass number of 24. So the name of the element is magnesium 24 because that's the mass number. The isotope symbol is already given to us up there, which is kind of nice. That's the mass number, mass number over the atomic number, and then the element symbol. And then the percent abundance, we take how many atoms of that isotope there are in the sample divided by the total number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 atoms, and there are a total of 20. And we're going to multiply that by 100. I'm running out of room. So my percent abundance for magnesium 24 would be 80%. Now you're going to do the same for this atom as well as this atom, but you guys can figure that out on your own. All right, so if we look down in this box, you're going to be using a formula that we weren't able to get to in class. It says on page 1, we calculated the average atomic mass of boron atoms by adding up their masses and dividing by 10. Since isotopes are more common than others, some isotopes are more common than others, we need to calculate the average atomic mass by using a special equation. Record the average atomic mass equation in the box below, then use the information about magnesium isotopes to practice. Okay, so my average atomic mass formula is going to be the mass number times its percent abundance plus the next isotope times its percent abundance plus the next isotope, mass number, times its percent abundance. And we could have hundreds of different isotopes, okay? And we can take all of that and we add it up and multiply it together and we divide by 100. And that's going to give us the average atomic mass of magnesium. So just as a heads up as how that would look, we would take the atomic mass, or the mass number for the first one would be 24 AMU times its percent abundance, which we calculated to be 80%. We would then add that to the mass number of the red isotope times its percent abundance plus the mass number of the third isotope times its percent abundance. And once we add and multiply all of those values together, we can then divide it by 100 to help us get the final answer. Now, this is in fact, this formula, This is what's going to help you on the questions to come like after this. So at the bottom of this page, and then on the following side of this page, the next page. So hopefully this helps.